If you remember, in the previous class, I was doing organic chemistry, and to be more precise, in organic chemistry, I was teaching you the chemical properties of methane and ethane. And the first chemical property of methane and ethane, which I had explained in the previous class, was like this. This is what I had explained in the previous class. Substitution reactions. I had explained you substitution reactions of methane and ethane, and then oxidation reactions of methane and ethane, complete oxidation or combustion of methane and ethane in excess of air. Okay. Then incomplete oxidation or combustion in limited supply of air. This also I had done in the previous class. Okay. Now, and catalytic oxidation of methane and ethane was also done, where using copper catalyst at 200 degrees Celsius, methane was oxidized to methanol and ethane was oxidized to ethanol. This also I have done in the previous class. After that, further oxidation of methanol to methanal aldehyde in the presence of copper tube 200 degrees Celsius was also done, and oxidation of methanol to methanoic acid is also done in the previous class. Ethanol also undergoes oxidation in the presence of copper tube to form ethanal acetaldehyde, which was the ethanol produced was further oxidized to ethanoic acid, which is called acetic acid. Okay, so till here I had done in the previous class before the examination, second term examination. So today is the ninth day, sorry, of myself transacting the lesson to you all, organic chemistry. Okay. So let us continue. Let us continue the chemical properties of methane and ethane. Now, the next chemical property under methane and ethane is like this. Methane, it undergoes oxidation in the presence of molybdenum oxide, MOO, molybdenum oxide, at a temperature of 350 to 500 degrees Celsius. And instead of getting oxidized, instead of becoming an alcohol, it is getting oxidized to an aldehyde, that is methanol, HCHO plus water. So this is methanol. Okay. So this is oxidation of methane in the presence of molybdenum oxide, temperature 350 to 500 degrees Celsius. Here, instead of an alcohol, an aldehyde is formed. So if you use molybdenum oxide, instead of alcohol, instead of methanol, methanol is formed. Okay. If I use ethane, C2H6, and oxidize this ethane in the presence of the same catalyst, molybdenum oxide, at 350 to 500 degrees Celsius, this ethane gets oxidized to ethanol, CH3CHO plus water. So this is ethanol. The common name of ethanol is acetaldehyde. It is acetaldehyde. Okay. And the common name of methanol is formaldehyde. Now this was oxidation, catalytic oxidation of ethane and ethane. Now we move to the next type of oxidation, which is called controlled and slow oxidation. Controlled, controlled and controlled slow oxidation, slow oxidation of methane and ethane. Methane and ethane. Controlled slow oxidation of methane and ethane. Now this controlled slow oxidation of methane and ethane, it is carried out in the presence of oxidizing agent. The oxidizing agent which is used, it is acidified, potassium K2Cr2O7, acidified potassium dichromate. Okay, it is acidified with dilute sulfuric acid. Okay, the pressure is kept high. The other conditions are pressure is kept high, and temperature is kept low. So under these conditions, methane and ethane, they they undergo slow oxidation stepwise. So let me show you the reactions. First one, using methane. So when I use methane over here, methane undergoing oxidation in the presence of potassium dichromate K2Cr2O7, it first forms methanol CS3OH. This is methanol in the first step. In the next step, the further oxidation happens in the presence of potassium dichromate. It forms methanol. And if you further oxidize methanol in the presence of potassium dichromate K2Cr2O7, it forms methanoic acid HCOOH, which is methanoic acid. Okay, so this sequence is very, very important. An alkane, methane is an alkane. It is a hydrocarbon. Upon oxidation by using acidified potassium dichromate, it is forming, first step, it is forming an alcohol. The alcohol is further getting oxidized to form an aldehyde. The aldehyde is getting further oxidized to form carboxylic acid. So this sequence which you see over here, it is important. And please try to remember this. So here we can ask you questions with regard to oxidation, slow oxidation of methane and ethane, and ask you, name the oxidizing agent used. It is acidified potassium dichromate. What are the other conditions required? The other conditions required are high pressure and low temperature. So it is a stepwise controlled slow oxidation. Similarly, if I use ethane, if I carry out controlled slow oxidation of ethane, then the reaction happens in a similar manner like the first one, C2H6 is the molecular formula of ethane. So this oxygen, nascent oxygen provided by acidified potassium dichromate solution K2Cr2O7. In the first step, it gets oxidized to an alcohol C2H5OH, and this is ethanol. C2H5OH, this ethanol. Please keep that in mind. Okay. So in the first step, you're getting ethanol. Ethanol. Now, further, this ethanol gets oxidized to ethanol CH3CHO. It gets oxidized to ethanol ETHANAL, ethanol. Further, this ethanol gets oxidized to ethanoic acid, that is CH3COOH. This is ethanoic acid. Ethanoic acid. Now, the common name of ethanol I've told you, it is called acid aldehyde. It is called acid aldehyde, and the common name of ethanoic acid is acetic acid. It is acetic acid. Okay, so these are the controlled slow oxidation of methane and ethane. Okay, so this you must remember. The next chemical property under oxidation under this methane and ethane is pyrolysis. That is number C, I can name it. Pyrolysis of methane and ethane. Now, under pyrolysis of methane and ethane, what is the meaning of pyrolysis? Pyrolysis means use of a high temperature, in the absence of air. So, whenever we subject alkanes, methane and ethane, to thermal or catalytic decomposition in the absence of air, it is called pyrolysis. So, first, what is pyrolysis? I'll write it down. Pyrolysis is the thermal or catalytic decomposition of alkanes. When I say alkanes, I'm talking about methane and ethane in the absence of air. At high temperature. So this is called pyrolysis. Okay. Now, here I'll give you the examples. First one is for pyrolysis of methane. So if I take methane and subject this methane to a temperature of around 1500 degrees Celsius, so 2 molecules of methane, it is going to produce ethane, acetylene, HCCH, plus hydrogen gas is given out. This one is ethane. Okay. This is dehydrogenation reaction. This is dehydrogenation reaction. It is called dehydrogenation reaction. Remember that. Okay. Again, similarly, if I use ethane, say the formula of ethane is C2H6. If I subject it to high temperature, 500 degrees Celsius, in the presence of a catalyst like aluminum oxide, Al2O3, alumina, then this ethane, it is going to convert it into ethene, 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 plus hydrogen is given out. So this one, it is called catalytic, it is called catalytic dehydrogenation, catalytic dehydrogenation. Remember that. Okay. So, so this was pyrolysis of methane and ethane reaction. Okay. So this completes the chemical properties of methane and ethane. Now we move to the next under methane and ethane uses of methane and ethane. Under uses of methane and ethane, the first use is like this. It is used as an illuminant. It is used. It is used as an illuminant. ILLUMINANT, illuminant means lighting purpose, and as domestic fuel. Domestic fuel. FUEL, fuel. Then number two, the next use is it is used in the manufacture of chemicals. It is used in the manufacture of chemicals. Manufacture of chemicals. The chemicals can be chloroform. First one is chloroform. Chloroform. The formula is CHCl3. Chloroform is used as a solvent also. It is used in waxes. It is used as an anesthesia also. Then it is used to prepare carbon black. It is used to prepare carbon black also. Now carbon black, it is used as a black pigment for making shoe polishes or ink for printers. Ink for printers. Okay. Then methane and ethane, it is used for preparing formaldehyde also. Formaldehyde also. Now formaldehyde, it is used as an antiseptic. It is used as an antiseptic preservative for biological specimen. It is used in the manufacture of methanol also. Methanol. Methanol is a solvent for varnishes. It is used as an antifreeze in automobiles. And the next use, it is manufacture of chemical. It is used in the manufacture of ethanol. Ethanol. Now, ethanol is also a solvent for resins. It is a low freezing liquid used in low temperature thermometers. Okay. So these are the two important uses of methane and ethane. Okay. Now, 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 I would like to pause my class over here for some time because I can hear a lot of background noise from the other end. From the other end, I believe some of you have not muted yourselves.
Ashwin, mute yourself.
सुमित स्कूल में छौ मैं क्लास 10 क्लास लिँदैछु कि पुरा ब्याकग्राउन्ड नोइज आउँछ
Hello,
माइक्रोफोन
sir.
क्लास 10 पुरा त्यो माइक्रोफोन अनै जस्तो लाग्यो कि मलाई पुरा ब्याकग्राउन्ड आउँछ पुरा नानीहरुलाई पनि म्युट गरेको तर पनि नोइज आइरहेको
Hello,
छ
sir. Sir, are you there?
अश्विन
Hello.
हेलो कुङ्को
Hello.
Hello.
कुङ्को
Hi.
Yeah. Hello, sir.
हेलो यस अश्विन
Are you there?
I am there I can hear a lot of background noise from back no that's disturbing the class please mute yourselves listen please mute yourselves
You're all muted only.
yeah that's what I can hear I rang to the over there to the other classroom over there because somebody has kept the microphone on no the teacher's microphone is on because I use my system no I don't use the school system so if the microphone on the other end is on we get a lot of background noise okay anyway thank you now I don't hear the noise anymore okay now let us continue with the class okay I am sharing my screen can you see the screen can you see the screen boys one of you respond
Yes, sir.
okay so mute yourself now now let us move to the next the second member of the homologous series of hydrocarbons the second member of the homologous series of hydrocarbons. What is the second member of the homologous series of hydrocarbons? Tell me, boys, any one of you. What is the name of the second member of the homologous? First one is
Alkene.
alkanes. Second one is, it is called alkenes. It is called what? It is called
Alkanes.
alkenes. Alkenes. Kenes. Alkenes. Now, under these alkenes, our syllabus is confined to the study of ethene only. Ethene only ethene. So here we'll be learning about ethene, the chemical properties of ethene. Okay. Now please note that alkenes are what? Alkenes are alkenes. Alkenes are unsaturated. They are unsaturated. They are unsaturated hydrocarbons. Unsaturated hydrocarbons. Okay. Containing a containing a carbon 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 double bond carbon carbon double bond they contain a carbon carbon double bond that is very important to note over here okay they contain a carbon carbon double bond okay now moreover these alkenes also known as they are also known as olefins o l e f I n s they are also known as what olefins. Please note that. That is very important. Alkenes are also known as olefins. Olefin means what? Oil producing. Oil producing. They are oily, which can make oils. Okay. Oil forming. I can say in short, better language, oil forming. Alkenes are what? Oil forming. That's why they are called olefins. Okay. Moreover, the general formula of alkenes is it is CnH2n. That is general formula of alkenes. Okay. Now, with regard to the reactivity of alkenes, please remember that alkenes Alkenes are more reactive. Alkenes are more reactive. Alkenes are more reactive than alkanes. More reactive than alkanes. They are more reactive than alkanes. Okay, remember this. They are more reactive. Why more reactive? Because of the presence of carbon-carbon, this double bond. Because there is a carbon-carbon double bond. One is a sigma bond, one is a pi bond. Because there is a pi bond, okay, that's why these alkenes are more reactive than alkenes. Remember that. Okay. What is the what are alkenes? Alkanes also known as, which I discussed in the previous classes. What are alkanes also known as? Alkanes.
Paraffins.
Correct. Alkanes are also known as paraffins. Paraffins mean low reactivity, less reactive. Paraffins mean less reactivity, low reactive. Okay. Now, this carbon-carbon double bond in alkenes, this carbon-carbon double bond in alkenes, it is called an olefinic bond. It is called an olefinic. It is called an olefinic bond. Okay, so this was with regard to introduction to the alkene, that is ethene. Okay, now with regard to nomenclature, I have discussed plenty of examples with respect to the nomenclature over here for alkenes in the previous classes. Okay, now I will straight away like to move further over here to the preparation of ethene. Preparation, lab preparation. Okay, so preparation, how to prepare? Preparation of ethene. Ethene. The common name of ethene is also known as commonly ethylene. ethylene, ethylene. Okay, ethylene. Remember that. Now in the laboratory we can prepare ethene by the dehydration of ethyl alcohol. So the first one, that is number A, let me write it down, number A, lab preparation. Lab preparation, lab preparation of ethene. It is done by by dehydration. Dehydration of ethanol. Ethanol. Dehydration means what? Removal of water as a molecule. Okay, so ethanol. Dehydration of ethanol. So if you remove water molecule from ethanol, then we will get ethene. So let me write down the reaction as well. So the formula of ethanol, it is like this: C2H5OH. This is ethanol. This is ethanol. So when I treat ethanol with concentrated sulfuric acid at a temperature of 170 degrees Celsius, or in the presence of alumina, heated alumina, Al2O3, at a temperature of 350 degrees Celsius, then dehydration happens. Dehydration of ethanol happens, and it results in the formation of ethene. That is, the formula of ethene is C2H4. This is our ethene, and then water gets removed. Okay, now this reaction, this is the chemical reaction equation for the preparation of ethene in the lab by using the method which is called dehydration of ethanol. Now let me write this in another form. One more form is there. The formula of ethanol can be written in this manner also: CH3, okay, then CH2, then OH. This is also ethanol. This is also the way we can write the formula, structural formula of ethanol. Now, when this ethanol it is treated with now either conc sulfuric acid at 170 degrees Celsius or heated aluminum oxide at 350 degrees Celsius, then it produces what? Ethene. Now how does it happen? See, now over here water is removed in this manner. HOH, this hydrogen from first carbon, OH from the second carbon over here. So water is removed. So minus H2O. So and the bond, this bond over here, this bond falls over here. This takes away the hydrogen. Okay, so we get HCH and the double bond between the two carbons, and over here H, over here H, plus water. Okay, so this is ethene, structural formula of ethene. So this is also one way of representing the chemical equation for the lab preparation of ethene by the dehydration of ethanol. Okay, so this is one method. We can also prepare ethene in the lab by, the next one is by dehydrohalogenation, by dehydrohalogenation. Dehydrohalogenation means hydrogen also out, halogen also out, both of them out. That's why it is called dehydrohalogenation. By dehydrohalogenation of bromoethane, bromoethane. So we can prepare ethene in the lab by using this method also. Now let me write the equation for you all and explain over here. So now here I'll write on the formula of bromoethane. Bromoethane has a formula C2H5Br. This is bromoethane. This is bromoethane. Let me write down the structural formula also. Structural formula of bromoethane becomes like this: CH3, then CH2Br. Okay. Now, when this bromoethane it is reacted with potassium hydroxide, alcoholic potassium hydroxide, alcoholic in an alcoholic medium. This potassium hydroxide is in alcoholic medium, and the reaction mixture is boiled. Okay, it is boiled, then it will result in the formation of ethene, C2H4 plus KBr, potassium bromide, plus water. So over here the halogen is out. Okay, the halogen is out, hydrogen is also out. Okay, so this same reaction in the structural form, I'm going to write down the equation. So when I react with potassium hydroxide, KOH, alcoholic, but it has to be alcoholic. Remember, it is important, alcohol. It is in alcoholic medium, and boil it. So what is going to happen over here? The potassium, it is going to remove this Br. Okay, and this OH is going to combine with this H to form water. Okay, and there will be formation of double bond over here. So that's how we get ethene. HCH, double bond CH, H plus potassium with bromine means potassium bromide, and OH with H means water. So this is also the second method of preparation of ethene, which is called by dehydrohalogenation. Dehydrohalogenation of bromethane or alkyl halide. Now remember, dehydrohalogenation of bromethane, it is carried out in the presence of alcoholic potassium hydroxide. If I don't use alcoholic potassium hydroxide, then I will not get ethene. I will get something else. Now what is that something else? Let me discuss that also. For example, if I take C2H5Br, that is bromoethane. If I take C2H5Br bromoethane and react it with potassium hydroxide, not alcoholic but aqueous. This is in water. Okay, if I perform this reaction, then instead of ethene, it will form what? It will form an alcohol C2H5OH. C2H5OH plus KBr. Now this is alcohol. An alcohol is formed. Ethanol is formed. This reaction, it is not called dehydrohalogenation. This is called hydrolysis. This reaction is called hydrolysis. It is called hydrolysis. So this is also a method to prepare an alcohol, which is not there in the syllabus, but there can be a question. If you use aqueous, what product is formed? If you use alcoholic, what product is formed? So this is one thing to be noted over here. There is a general method also for the preparation of ethene. The general method, it is by the general method of preparation of ethene, it is by, it is called by crackling, CRACKING, cracking or dehydrogenation, or dehydrogenation. Now, by cracking or dehydrogenation means use of high temperature. So if I take ethane, CS3, CS3, okay. If I take ethane and subject this to 500 degrees Celsius in the presence of heated alumina, silicon dioxide, which is the catalyst, combined catalyst, it forms H2C, CH2 plus hydrogen is given out. So this is our ethene. So this is the general method, but more important than the general method, it is the lab method of preparation by dehydration and dehydrohalogenation reaction. Okay. Now, so this was the preparation. Now we move to the next, that is called physical properties of ethene. Physical properties of ethene. Physical properties. Physical properties of ethene. Now let us discuss them one by one quickly. Number one, ethene, it is a gas. It is a gas at ordinary temperature. Ordinary temperature. Gas at ordinary temperature. Colorless. Colorless. It has pleasant smell. Pleasant smell. It has a pleasant smell. Okay. Number two, slightly soluble in water. Ethene is slightly soluble in water. Okay, remember that. But it is soluble in organic solvents. Soluble in organic solvents. Okay. Number three, it is slightly less dense. Less dense than air. Okay, so this much you try to remember with regard to the physical properties of ethene. Now, the chemical properties I will discuss in the next class. So I'd like to end my class here only, but before that, just hang on over there because I need to record the attendance for today. Okay.
So what do you mean by this? Pleasant smell.
Pleasant smell means nice smell. Nice smell. It is not a foul smell. Okay. Thank you so much. Have a nice day.